let's get on with it. Okay, so I thought that we should maybe stick with complex types of identities. I think you guys enjoyed doing them on Tuesday, at least I hope so. So I just wanted to show you a few more things and then show you some other sorts of questions that could potentially come up. Okay, all right, so often in trig, they give us these sorts of questions where they want us to prove an identity and then it says hence calculate. So they could expect us to be able to do something like this as well. Question B, provided that we've been able to prove that A is true. Let's just grab, sorry guys, I should have bought this from the last time. I know you always like to have these here. So let's just snap that over there and we can just make it a little bit smaller. Okay, so there are our identities. Let's just make that a little bit smaller. I hope you guys can see that. I'm just gonna pop that in there like that. Okay. All right, so let's have a look at question A, and then I'm going to give you guys a question to try that's similar to this after this. Okay, so on the left-hand side, we have 1 minus tan A over 1 plus tan A. All right, so what are we going to do with our tan A? What are we going to do with tan A? You can pop it into the chat, or if you want to unmute. What would we do with tan A? We would use our tan identity, right? So we would write this as sine A over cos A. In the denominator, we'd have something similar, but we've got 1 plus sine A over cos A. Now here is the super cool part, all right? In the numerator, you are subtracting fractions. In the denominator, you are adding fractions. What are the rules for adding and subtracting fractions? Can anyone remember? What are the rules for adding and subtracting fractions, Matrix? Exactly. So, Naledi, how should I rewrite the 1? If I want a lowest common denominator, how should I rewrite the 1, do you think? Any ideas? How should I rewrite the 1? If I write it as Tando, go for it.
Hi, ma'am.
Hi, Tando.
Ma'am, aren't we supposed to rewrite the 1 as cos squared A plus sine squared A?
Yes, in certain situations. But would you believe, Tando, that rewriting 1 as sine squared A plus cos squared A in this situation is not going to help you at all? That's what's so cool about this particular question, because this is going to be something that you've maybe never considered before. Let's think about it. We know that 1 is sine squared A plus cos squared A, all right?
Yes, ma'am.
But now we're going to end up with a trinomial. We've got 2 different fractions that don't have the same denominator. It's going to start becoming really, really uncomfortable and difficult for us to work with. So how else can we rewrite 1? Not a conjugate yet, Naledi. Not a conjugate yet. Remember 1.
Ma'am,
Yes,
are we
Tando?
supposed to write it as cos A over cos A?
Oh, you brilliant child. If I could jump through the microphone and hug you right now, I would do that. But excellent. Well done. You've put 2 and 2 together about what I was saying about the same denominator. Excellent. I'm so glad you said that. That's brilliant. So there we go. We are rewriting this 1 over here as cos A over cos A. Anything divided by itself is 1 minus sine A over cos A. Divided by, guess what? We're going to rewrite 1 as cos A over cos A plus sine A over cos A. All right, so we want the denominators to be the same so we can add and subtract our fractions. Okay, and as per usual, I'm running out of space. Okay, so what I'm going to do is I'm going to go up here and I'm going to write next to it, even though you would typically write your answer underneath, and then at least it's also all on the same page when you guys want to take a screenshot. Okay, so when we add and subtract fractions, we keep our denominator and we subtract our numerators, right? So that means in our numerator, we have cos A minus sine A over cos A, all over or divided by cos A plus sine A, all over cos A. Now you are dividing fractions. So when you divide fractions, the rule is tip and times, or keep, flip, change. So we're going to keep cos A minus sine A at the top and cos A at the bottom. We're going to change the divide to a times. And we were going to put what's at the top at the bottom and what was at the bottom at the top. Okay, so cos A is going at the top and cos A plus sine A is going down at the bottom. Okay. Now I'm going to cancel cos A with cos A, and we're going to end up with cos A minus sine A over cos A plus sine A. Right, but I'm not finished. Okay, I'm not finished. If I go back and have a look, I have not got what is on the right-hand side. On the right-hand side, I've got cos 2a over 1 plus sine 2a. So I'm not there yet, but you guys are absolutely brilliant. Okay, Tando, thank you so much for the cos A over cos A. And I'm going to go back to the chat and I'm going to go and look at what Naledi was saying. Naledi said conjugate. All right, yes, Naledi, remember I said not yet. Not yet, but now it is time for the conjugate. Okay, so Naledi, what do you suggest we multiply by since you said the word conjugate? What do you suggest we multiply this by? What conjugate are we using? Naledi? I don't know if the rest of you remember, those of you that were certainly here when we did our trig course, we spoke about conjugates. I'm not sure if you guys remember that. I hope you do. Does it sound familiar? Thumbs up, thumbs down. Conjugate. Yes or no? Does it sound familiar?
Ma'am, hello, ma'am.
Hello, Tsegofatso.
Don't we use sin A plus sin, cos A plus sin A?
We would. We would.
Yes.
Correct. Correct. So we would use cos A plus sine A
Over the same one.
over the same one. Good. Well done. Lovely. Okay. And now when we multiply, we're multiplying numerator with numerator, denominator with denominator. So that's going to give us cos A minus sine A multiplied by cos A plus sine A. And at the bottom, we've got cos A plus sine A multiplied by cos A plus sine A. All right, and again, I know you would be writing in your books. I'm just going to pop it up here. When we do FOIL at the top, we would end up with cos squared A minus sine squared A. That's difference of two squares. At the bottom, we're going to end up with cos squared A plus 2 sine A cos A. Sorry, all over. And then here would be sine squared A, like so. All right, and now we're on our last step. Okay, cos squared A minus sine squared A is one of our cos double angles. It's the first one over there. So there we go. We're getting our cos 2A at the top. And cos squared A plus sine squared A is 1. So that's where this 1 comes from. And 2 sine A cos A is our sine double angle. So we would have sine 2A at the bottom. Okay, all right, so that is a difficult question. A lot going on there. Please do take screenshots. Any questions before we move on and do part B? Are we all good? Keith Lynn's happy, Tundo's happy. Lady, I presume you're happy. Okay. Desejo, Shisana, go Nicole, Trish, Setu. All right. Good stuff, everybody. Okay, let's jump into the second part. So we know by now that in maths, if they tell us hence, we've got to use what we've done before. All right, so if it says hence or otherwise, then we're allowed to use a different method. We don't have to use what we've done before. But if it says hence, we have to use what we have done before. Otherwise, we're not going to get any marks. So they are saying to us, hence, I'm sorry, let me just put that down. No, it's not going to go any further over to the side. Calculate 1 minus tan 22,5 over 1 plus tan 22,5. So what does that look like? What does 1 minus tan 22,5 over 1 plus tan 22.5 look like? It looks like the left-hand side, doesn't it? That's what it looks like. It looks like the left-hand side of our original identity. Okay, so these two over here are linked to one another. That's what we see. This is the connection. Okay, so if the left-hand side equals the right-hand side, then I can work with this as though it was the left, and I can produce what was on the right-hand side for with it. Okay, so what that means, what they are trying to tell us here is that A must be equal to 22.5, right? So we've got cos 2 times 22,5 over, let's just scooch down a little bit, one plus sine 2 times, whoopsie, sorry, not supposed to be 2 comma, beg your pardon, 2 times 22,5. Okay, so this gives us the cos of 45 at the top. At the bottom, we've got 1 plus the sine of 45. And of course, those are our special angles. Okay, so what I'm going to do now, I'm just going to move, this is what you guys are going to do next. Okay, so special angles. We know that the cos of 45 is root 2 over 2. Make sure you know your special angles 100%. And we know that the sine of 45 is also root 2 over 2. So what I'm going to do is I'm going to write 1 as 2 over 2 plus root 2 over 2 to make my denominators the same. And that's going to leave us with root 2 over 2. And that is being divided by 2 plus root 2 over 2. Tip and times. So that's going to leave us with root 2 over 2 times 2 plus root 2 over 2. I can't cancel any terms, but I can cancel. Oh, no, I can't cancel. Oh, sorry. Silly me. Sorry, beg your pardon. I did the times, but I forgot to do the tip. There we go. So we've got 2 at the top and at the bottom 2 plus root 2. And now that I fixed my mistake, that 2 there and that 2 there can cancel. So our final answer would be, let's just move this down a little bit more. So our final answer here is going to be root 2 over 2 plus root 2. And that would be it. Okay, we have now found the value of, or calculated 1 minus tan 22.5 over 1 plus tan 22.5. Okay, any questions? Are we all good? How are we feeling? Hopefully strong like a lion. Good, there we go. Like the smiling faces. Good, okay, thumbs ups, excellent. Good. Nice, guys, well done. Okay, so I'm not going to waste any more time. You are going to do this question over here. Okay, so similar idea. Off you go. Let me just bring this down for you. And I'll just pop it over there. There you go. So at least that's on the screen for you. Good. All right, off you go. And when you're done, you can say done. Done means you've done part A and part B. And again, if you get stuck, Yolanda and I are here to help you. There we go. Good. All right, so this wasn't as difficult as our example. This is a little bit easier. Cool. Good, C. Well done. Bridget's done, Tando's done, and Pafatso's done. Cole's done, and Asejo's done. Okay. So we'll just give the others another minute or so. I'm just writing down the question in the meantime. Okay, Jordan's done and Barley's done. Good, Lorato. Okay. All right. So we should all be finishing off part A, if not finished everything by now. Here, part B again was a slightly longer than what part A was. So we would rewrite sine 2 alpha, as we know to do, as 2 sine alpha cos alpha, right? That's our sine double angle. At the bottom, remember from Tuesday, we want to get rid of the 1 if we can. So we're going to rewrite cos 2 alpha as 2 cos squared alpha minus 1. That leaves us with 2 sine alpha cos alpha over 2 cos squared alpha, because the 1's have now added up to 0. We don't have any terms. We've only got times and divide, so we're allowed to cancel. 2 divided by 2 is 1, and cos theta, or cos alpha at the top and a cos alpha at the bottom, means there's a cos alpha left over. And now we are left with sine alpha over cos alpha, and that's what we wanted because that's equal to tan alpha. Okay, so that part wasn't too bad. You get a mark every time you use an identity. I think there would be an accuracy mark for simplifying and then getting to sine alpha over cos alpha correctly. Okay, there obviously wouldn't be a mark on the answer because it is given to us. All right, so that was part A. Let's go and have a look at part B. They've said to us, hence calculate the tan of 75. So again, we can see the link here. Here's the tan of alpha. There's the tan of 75. This is our connection. All right, so that means that the tan of 75 has got to be equal to what is on the left-hand side. So the tan of 75, they are implying that alpha must be equal to 75. So that's equal to the sine of 2 times 75 over 1 plus cos of 2 times 75. So this gives us the sine of 150 over 1 plus the cos of 150. Now we have to use our grade 11 reduction formulae. Okay, so 180 minus 180 plus 360 minus. Okay, so we know that sine 150 would reduce to sine 30, and 1 plus cos 150. It's an obtuse angle in the second quadrant where cos theta is negative. So this is going to reduce to negative cos 30. Okay. Now we can use our special angles. So we've got sine 30 at the top, which is a half. And we've got 1 minus cos 30 at the bottom. So this is going to be 1 minus, and the cos of 30 is root 3 over 2. Okay, so again, now we're in a situation where we've got to work with fractions. So I'm going to leave the half at the top. I'm going to write divided by. I'm rewriting 1 as 2 over 2 minus root 3 over 2. So I've got to do that, but first, what was in the denominator? All right, so again, you would write underneath. I'm being naughty and writing up here. So that's 1 over 2 divided by 2 minus root 3 over 2. Okay, so bonga, that comes from the hence. Okay, so remember I was drawing pink circles around it? Okay, so if they've said we've proved that the left-hand side equals tan alpha, and now they want us to calculate the value of tan 75 is our tan alpha. So we are taking what was on the right and we're making it equal to the left over there. Okay, so we've got to see the connection in the questions. Okay, you see now, all right. Okay. Right, tip and times, so that gives us 1 over 2 times 2 over 2 minus root 3. Okay, we can't touch anything that's inside there. That's off limits. 2 divided by 2, and that leaves us with 1 at the top and 2 minus root 3 at the bottom. Okay, and now we've worked out the value of the tan of 75. Okay, are there any questions? Did you guys get that? Okay, so Jordan, I suppose you could if you wanted to, but I mean, that's just going to make it more complicated. You know, if you can reduce, if you can sort of try and sort of, yeah, I mean, use compound angles when you're forced to. But if you're not forced to use compound angles, don't, because it's going to end up making things a lot more complicated. You know, our normal grade 11 reduction formulae here are the easiest way to get to the answer. So I certainly wouldn't go, you know, and start writing things like sine 30 as, yeah, in a different way. No. Okay. Remember, maths is difficult enough. Don't make it more complicated than it needs to be. All right. So they would have to give us a mark for subbing in. Or maybe the mark wouldn't be here. Maybe the mark would be over there instead. More than likely. Reducing. Special angles. And then we'd probably in matric, we would only get a mark for our answer. Okay, so that could be out of 4, and that could be out of 4. All right. Are we all good? Thumbs up, thumbs down? Are we happy? Any questions? No, so you do not need to rationalize the denominator. Okay, in grade 11, that's an expectation, but in matric, just like with calculus, where you're allowed to leave things with negative exponents, you don't have to rationalize the denominator. Okay, there are not going to be any marks for that. All right, there's a whole bunch of thumbs ups. That's good. I'm pleased. So let's barrel on to the next thing. Okay, so here we go. The reason I am doing question I and question K with you is because I want you to see the different situations when it comes to the cos 2b, all right? Often it creates a lot of confusion. With cos 2b, you've got three options. How do you know when you are working with identities which of the options to use? So that's why I'm doing these questions with you. Okay, so I'm just sticking that over there. All right. So I'm just trying to find my pen in the dark here. Okay, I've got it. All right. So when it comes to cos 2b or cos 2a, it depends what it is combined with. So cos 2b is in the numerator with cos b. If you see cos 2b with cos b, it is easier to make a trinomial out of it and to write it in terms of cos only. So choose 2 cos squared b minus 1. Okay. In a situation like this question over here, cos 2x is with sine x. So when cos 2x appears with sine x, write cos 2x as 1 minus 2 sine squared x. Okay, so if cos 2b is with cos b, write cos 2b as 2 cos squared b minus 1. If cos 2b is with sine x, write cos 2x as 1 minus 2 sine squared x. Thumbs up, thumbs down. Does that make sense to everybody? These are just some hints as to how to approach these problems. Does that make sense? Yes, you happy? Okay, all right. So what I'm going to challenge you guys to do is the next two questions on your own. All right, I want you to get started on I, and we'll mark it. And then we can do the next one as well. Okay, if you finish I, let me know, say done, and then I can pop the other one up on the screen for you. Sorry, I know I'm pushing you a little bit tonight. I hope you're enjoying the challenge. Brilliant, Zechovatso. Okay. Guys, don't stress. I'm going back up there now. Okay, so there's the next question, Zechovatso. And then I've got something else to show you as well, Zechovatso, and anybody else that's flying through these. Let me know when you're done with I, please, guys. Okay, so is Tando. Okay, go on to K as well, Tando. Well done. Nicole, go on to K as well. Good, Bridget. Try K now. All right, Tando, you're done with K. Lovely. Okay, so Tando, I don't know if I'm going to fit this onto the screen as well. Sorry, guys, just give me 1 second. Okay, there's another one. Okay, Tando. Okay, Nicole, you can also start looking at the next question. All right, so those of us that were busy with I, we should all be pretty much close to being done with I. All right, so remember we said if we saw cos 2b with cos b, we would rewrite cos 2b as 2 cos squared b minus 1. So that's how come we've got that as a trinomial at the top. At the bottom, I can only write sine 2b in one way. Factorizing, canceling down, and that will leave us with what we have on the right-hand side, which was cos b plus 1 over sine b. Okay, so we should all be done with I. That's not a particularly difficult question. Double angle identity factors. That would probably only be out of 3. Okay, so we are either on question K or this question over here, which I've just stuck on the screen with the sine 3 theta in it. Are there any questions about I? We should all be all right with I. We should all be going on to K. Okay, so Lesedi, are you talking about the denominator in I, Lesedi? Do you mean the denominator? Okay, so if you've taken out sine B, then what's left is 2 times cos B. And then because you took out sine B, that's why you've got the -1 over here. So in other words, sine B times 2 cos B would give us 2 sine B cos B, and sine B times 1 would give us minus sine B. So if I remove the brackets here, I would go back up to that step above. So Lesedi, it's exactly the same as this. Imagine you have 2xy minus x. Yes? If you took out x as a highest common factor, you'd be left with 2y minus 1. It's exactly the same idea. Okay, all right. Again, if you are finished with K, let me know, please. How's it going with K, Matrix? With question K? Are we okay? Done with K? Okay, Pinga. Katleho, go for it.
Oh, ma'am, I was looking for the identities, ma'am. Sorry,
Oh,
ma'am.
okay, they're there. They're there. Sorry. I suddenly realized you may need them. That's why I went back up. Yes, I'm going to wait another couple of minutes and then I'm going to start with K. It's because we're starting to run out of time now. Done with K as well. Okay, Ma. Okay, so I'm going to start with K now because I don't want us to run out of time. If you are busy working on the third question, then I suppose you can just check back just to make sure that you've got this correct. Otherwise, this is what we would do, okay? So cos 2x appears with sine x. So what we are going to do is we're going to rewrite cos 2x as 1 minus 2 sine squared x. Okay, but we've got to use brackets because of the minus sign. Okay, so 1 minus 2 sine squared x minus sine x. And again, at the bottom, there's nothing that we can do with sine 2x other than write it as 2 sine x cos x minus cos x. Okay, so this at least gets us a couple of marks. Always a mark for using an identity. All right, so now at the top, we're going to remove the brackets. 1 minus 1 means the 1's going to go away, and we're going to end up with positive 2 sine squared x minus sine x at the top. And at the bottom, we're still going to have the same thing. So 2 sine x cos x minus cos x. And again, we're going to factorize. At the top, we're going to take out a highest common factor. That's going to leave us with 2 sine x minus 1 in brackets. At the bottom, we're going to take out a highest common factor. We're going to take out cos x. Hopefully, we end up with the same thing in brackets, and we do. 2 sine x minus 1. Okay, and again, cancel what was at the top with what was at the bottom, and we end up with sine x over cos x, which leaves us with tan x, which is what we had on the right-hand side. Okay, so how did question K go? Was that good? Did it go well? Are we happy? Are we crying? Tell Yolanda and I. How are you feeling? Good. Good, Setu. Good, Nicole. Good, Loki. And Bali up and down. Yeah, I know, Tando. That's why Katlego didn't use brackets. Okay, Katlego, I cannot emphasize how important it is to use brackets when it's appropriate for us to do so. Okay, so when we are substituting, when we are subtracting binomials or trinomials, you've got to use brackets. Okay, very, very important. Let's just chat very quickly about what would happen in the third one. Yeah, Tsechofatse, that's why I've given it to you. Okay, because I wanted it to be something that you would think about for a little bit. Okay. Any ideas? Anyone got any ideas what we could do with sine 3 theta? Ah, there we go. Okay, Natalie. Always use brackets when you substitute. Remember, whenever you are substituting for cos 2x, you're always going to be substituting a binomial. Whether it's cos squared a minus sine squared a or 2 cos squared a minus 1, it's always, aha, Jude. Nice. Okay, compound angles. Indeed, Jude, how are we going to write 3 theta? You guys are on fire tonight. Beautiful. Jude, how are we going to write 3 theta? Any ideas? The sine 2 theta plus sine theta. Okay, so in other words, I think what Jude is trying to say is obviously difficult to type on the phone, all right? But just very quickly in the last couple of minutes, and then try this question at the start of our next course. I can go through the answer, but just I want you to try it by yourselves, okay? You can rewrite sine 3 theta as sine 2 theta plus theta. Okay, and then use compound angles. You can write cos 3 theta as cos 2 theta plus theta, and then use compound angles. Okay, so good thinking, Jude. Well done. So from here, we would go to our compound angles. It's okay. Yes, Tando. Okay. All right, so that's how they could bring compound angles into identities for you. Okay, Matrix, as I say, I promise I will put this question up at the beginning of the start of our next course. Okay, and I will go through it then with you, but I want you to try it by yourselves. Okay, it doesn't help me doing it now for you. I want you to go away, try and do it. You've got some clues now. You're thinking about things in this maybe in a slightly different way.